Veyra, the frozen world. Veyra is a frigid terrestrial exoplanet located approximately 61.43 astronomical units from its host star, roughly twice the distance between Neptune and the Sun. At this range, solar energy received at Veyra is less than 1% of what Earth receives. The planet has a diameter of 18,000 kilometers, approximately 1.32 times that of Earth, and a surface gravity of 0.8 g, meaning objects on Veyra weigh about 15% less than on Earth. Despite its larger size, the low density suggests a composition rich in lighter ices and silicate materials. Veyra's atmosphere is composed predominantly of nitrogen and has a surface pressure of 0.3564 atmospheres, roughly 1/3 of Earth's atmospheric pressure at sea level. This atmosphere is insufficient to sustain liquid water without pressurized enclosures and provides minimal protection against cosmic radiation. Surface temperatures average -201 degrees Celsius, nearly 4 times colder than the coldest temperatures recorded on Earth's Antarctic plateau. Even during its brief summers, Veyra's sunlight remains too weak to significantly alter surface conditions. The extreme axial tilt of 49.35 degrees, compared to Earth's 23.5 degrees, causes exaggerated seasonal cycles where polar regions experience multi-decade periods of darkness and cold. Unlike Earth's robust hydrological cycle, Veyra's environment features a cryogenic weather system where frozen nitrogen and methane dominate, forming glaciers, surface frosts, and occasional atmospheric precipitation in the form of nitrogen snow. Earlier colonization proposals theorized that orbital mirrors and atmospheric engineering could establish limited habitable regions, similar to experimental biodome projects on Earth. However, the instability of Veyra's thin atmosphere, compounded by its extremely long orbital period of 341 Earth years, rendered sustainable colonization infeasible. Currently, Veyra is classified as a non-habitable world. Its slow geological cooling, diminishing geothermal activity, and increasingly brittle surface environment make it a prime subject for studying planetary atmospheres on the brink of collapse. A fate Earth's own climate systems are far from, but not immune to under extreme conditions. Veyra endures as a frozen relic, offering scientists a stark contrast to Earth's comparatively warm and vibrant biosphere. Veyra's rings and moons. Veyra is surrounded by a spectacular and massive ring system, one of its most visually dominant features. The rings are dense, composed primarily of fine ice particles mixed with dust and rocky debris. While Saturn in our solar system is famous for its rings, Veyra's rings are even wider and more chaotic, stretching tens of thousands of kilometers and casting permanent twilight across the surface. Orbiting within and beyond these rings are Veyra's 4 known moons. The primary moon, designated Veyra 1, measures approximately 2,187 kilometers in diameter. For comparison, Earth's moon measures 3,474 kilometers, making Veyra Y about 63% the size of our moon. Despite its smaller size, Veyra Y holds extraordinary scientific and economic interest. Geological scans suggest the presence of Velunite, a theorized exotic crystalline mineral formed under extreme cryogenic and tectonic conditions. Velunite is predicted to possess unique superconducting properties, maintaining quantum stability at temperatures far higher than any material known on Earth. If mining operations were ever feasible, the Velunite reserves on Veyra Y could be valued in the hundreds of trillions, even gazillions, of Earth dollars, revolutionizing energy transmission, quantum computing, and advanced propulsion technologies. Beyond Veyra I, 3 smaller dwarf moons orbit. The first and second dwarf moons are roughly 22 kilometers and 22.4 kilometers across, each resembling large, heavily cratered asteroids rather than spherical bodies. The third and smallest dwarf moon measures only 16 kilometers in diameter, barely larger than major asteroids like Phobos orbiting Mars. These dwarf moons, likely captured remnants of the early system, orbit at greater distances and are composed mostly of porous rock and ice. The dynamic gravitational interactions between Veyra, its moons, and its massive ring system lead to frequent debris storms, making the near-space environment extremely hazardous. Any future mining missions would face not only extreme cold and radiation, but the constant threat of high-velocity micro-impacts. Yet despite the dangers, Veyra the Rome's potential remains, a frozen vault of unimaginable value orbiting a dead world. The perils of Veyra. Despite its breathtaking beauty and extraordinary resource potential, Veyra is not a world that welcomes visitors. The planet's harsh surface conditions pose challenges unlike any encountered in known space. With an average temperature of -201.89 degrees Celsius, even the most advanced thermal shielding developed by Earth-based engineering struggles to survive for long periods. Standard robotic probes experience material brittling within hours, their metal frames weakening under the relentless cryogenic cold. The thin nitrogen atmosphere offers little protection from cosmic radiation. Ionizing particles bombard the surface constantly, saturating electronics with noise and accelerating mechanical failure. Landing operations are further complicated by the ever-shifting debris clouds. Fragments from the ring system routinely plunge toward the surface at hypersonic speeds, striking with forces equivalent to small-scale detonations. Subsurface exploration presents even greater dangers. While pockets of underground ammonia oceans have been theorized, breaching the frozen crust could release sudden, explosive geysers of trapped volatile gases, an unpredictable hazard that could tear apart even the most reinforced drilling rigs. Moreover, Veyra's extreme axial tilt means that one hemisphere spends decades in near-permanent darkness, while the other endures weak, glancing sunlight, destabilizing any attempt at long-term colonization planning. Infrastructure designed for one set of conditions would rapidly fail as the planet slowly rotates into a new environmental phase. If future missions attempt to exploit the Velunite reserves hidden within Veyra the Wire, they must not only endure these dangers, but also solve the colossal challenge of transporting the material across an orbital environment littered with high-velocity micrometeoroids and unstable gravitational fields. Veyra stands as a monument to the extreme, beautiful yet deadly, rich yet unreachable. A silent reminder that, in the cosmic balance between opportunity and risk, some worlds are better observed from afar. Thanks for watching. If you like this kind of content, don't forget to subscribe. We have so much more to explore. Curious about Veyra's neighboring planets? Hit subscribe and join us on the next journey.